and then we'll go from there. I might give you some ACs that are just like classwork. I won't necessarily mark them. So when we talk about tolerance, you need to understand, okay, the definition of tolerance. And I will really emphasize this part right here. If you highlighted it already, I would put brackets around it because this is tolerance as a definition, right? So tolerance is a range of acceptable measurements. Okay, it can also be described as measurement variation allowed, so that it can still be used for its intended purpose. Okay, so every industry has a little bit of tolerance. They allow variation. And I know you're probably saying, I listened to this yesterday. Why are you saying it again, right? Because I'm emphasizing the important parts. If an industry would not have any tolerance, they would have a lot of waste, right? They would, oh, you're off by a little bit, garbage, right? So you can't have that. So you have some tolerance. You allow for some variation. Did you hear me talk about why? So this is the big. I'm going to give you some examples here. So if you assemble doors, if it's too small, there's going to be a large gap. So on a windy day like today, there's going to be drafts coming in. That's not cool. You're going to have bugs coming in, right? That's not cool. Or in this case, warm air can escape, cold can come in. So it's not good if it's too small. If it's too large, in this case, the door wouldn't fit, okay? You would just not be able to close that door. So, but there is a little bit of tolerance. So basically, the difference between it being too small and too large, that is what we would say this is allowed, right? So there is a bit of leeway, but it can't be too small, it can't be too large, but just right. There's a bit of a gap, right? So here's the difference, because sometimes you might say, hey, what's uncertainty? What's tolerance? Okay, uncertainty, highlight this part. I will underline that too, because I already have this in the video, right? Uncertainty is due to the measuring device, like the limitation that the measuring device itself has. That's the reason that every measurement, like, right? Example, if you see something measuring 4 feet, we no longer, in this unit, we're not happy with that measurement. We would say, no, it's 4 feet plus or minus half a foot. Okay, so this is uncertainty, because the precision, what's the precision of that device, by the way? If I just showed you 1 foot or like 4 feet like that, what's the precision of the measuring device? 1 foot, right? It's 1 foot. And how do we get our uncertainty? We take the 1 foot and we divide it in half. That's 0.5. So we're saying, because this device is limited to 1 foot at a time, like that's the smallest increment, we are assuming that you could be off by half a foot on either way, on either the high end or the low end. So that's what uncertainty is. It's based on that measuring device, okay? Tolerance is different. It's determined, right? It's set by the industry, and it can be caused by the following, right? Human error, like if you don't run your machine properly, if you don't calibrate it, you don't clean it, right? Equipment malfunction, like sometimes something goes wrong with the machine itself. And also because of the limitation of the measuring device. So these things contribute to that. So maximum allowed, write that down here, and minimum allowed. Okay, so there's a bit of a back and forth there. All right, so it's everywhere. You just don't talk about it. Anybody work in a place where you deal with tolerance? Would you be willing and brave to share? Like I know that some of you might be working somewhere. Like I used to work at Kitchen Craft. I don't know if it's on the previous video you watched, but we would measure everything. Do I have my caliper here? Yes, I do. I stole it from Kitchen Craft. I'm just kidding. I didn't. It's mine. But like if a piece of wood got ripped, came out of the machine, every 15, 20 minutes I would check. This one doesn't work, but it would actually tell me what the width was of this piece. If it wasn't, I'd stop the machine immediately, check the blades. If the blades are dull, it would rip more. So you'd be off, it's not acceptable. Because if you ran this machine for hours and your measurement is off, even by a millimeter, I would get in big trouble, right? Because you wasted all that wood running it through, right? So Kitchen Craft would tell me, hey, this can be 44 millimeters or 46. 45 is perfect, but we allow some leeway there. Okay, that's why you have like a minimum and a maximum. Okay, let's talk on page 38 here, and I'll give you more examples after this. So go to 38 here. I would like you to. I'm gonna come up with a clever way of helping you out with this one, like on your study sheet, not just on this. Okay, but when you're stating tolerance, you need to know 4 things. Okay, that is important. You need to know these 4 items here. You need to know what is the maximum acceptable measurement, what is the minimum acceptable measurement, what is the nominal, which is what we call the target, like what are we ideally aiming for. Okay, ideally you want all parts to measure this. And then tolerance is the range or variation allowed. Okay, I will put that down. I have it here. But if you want to know tolerance mathematically, is taking the maximum and subtracting the minimum from it. That is the range or the variation. So if you want to add that, if you haven't done anything, just add what you see, right? Okay, so think of it this way. If there's a minimum and a maximum allowed, then anything inside of this, by the way, this could be, hey, this is perfect, right? So that would be allowed in this industry. It could be that a different factory says, no, 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 we don't want that much variation, so there's less wiggle room. Okay, but anything within the minimum and the maximum is acceptable. Anything above or below is discarded, is garbage, right? Like we will either recycle it or whatever, what have you. Okay, so this is the tolerance. So I would say from here to here is what we would call tolerance. Okay, it's another concept. Now, coupled with this, there are 4 main ways to express, right? This is important. I'm going to underline this. If you have a different color, there are 4 ways to state tolerance. Who came up with these? They told us, right? They just gave us it's like, hey, these are the 4 acceptable ways to state your tolerance. Okay? Here's the kicker. I could give you any of these formats. You can extract, remember you need to know these 4, right? You can extract that information and then write it in each of the other formats. So that's the thing I want you to understand here. Okay. Can you pay attention to this part? Because this is the one that is an easy mark and a lot of times it's missed. So you're paying attention, right? The big number up front, maybe I'll use the big number up front. When you see a big number on its own, that is always the nominal. Okay. So I will say this. Always, if you see a big number up front, that is the nominal for sure. It is like, that's what we're aiming for. And you're like, well, Mr. Jackson, you told me that that's the min. That big number is the min. Yes, it is, but it's also what we're aiming for. Okay? And you're like, wait a minute, this is max, like this. Why are you saying this is the nominal? Because that's what you're aiming for. You want the max, if at all possible. Okay? I don't know if you caught this yesterday. If you watched this lesson, you need to make sure you understand this part. Make a star here. This is the only trouble case right here. If you're given tolerance just like that, like two numbers, like this is the max, this is the min, you need to figure out the nominal. And this is how you do it. You add them, and then you divide it in half. You're finding the average when you're doing that. Okay? You add them, you divide it in half. Okay? Soon you'll get to work on this, so we'll practice a few. All right. Make sure you have this. Let's go to 39 here. How far did I go on the video? I think I did 39, right? I see some of you nodding because obviously you did it. Okay, way to go. So that means 40. Did I do 40 on the video? Page 40? Okay, we'll do 40. Take my brand new copy here. Okay, let's see if we can kind of guide you through this process. Okay. You try. Okay, this is on page 40. The tolerance for an official soccer field is given below. Okay. You see this. Which one, like if you look at this, I'm going to ask you to have these 4 formats on your study sheet. Which one does this look like? And I would say, look at this one. It says -0, correct? This one has -0 right there. So this format is already given, right? This is given. We don't have to write it like this. We already know that this is written in this format. Okay, guys? You're with me, right? You need to know these. Need these every time. You're going to fill this in. So you're going to look at it and be like, okay, what goes in here? What's the first number I want you to write down? This is the one I want you to write down first, if at all possible. That is your nominal. So I'm going to go arrow over to there. You're going to just write that down. 110 yards is what you're aiming for. That's the first step, okay, that I took. You don't have to necessarily do it this way, but the next would be getting your max and your min. To get your max, just watch my finger and my pencil here. I go 110 plus, in this case, it's 10 yards. So to get the maximum allowed measurement, you just add them up. That's 120 yards. Okay. To get the minimum, you either just realize, hey, this is the minimum, but not always. So in this case, it would be 110 minus 0. I know it's a bit silly, but sometimes this isn't a 0. So you might be like, what? Right? So in this case, it's minus 0. So it's 110 is my nominal, but it's also the minimum. It's both at the same time. The tolerance is max minus min. Sorry, what happened there? So you just go take your maximum, subtract the minimum, so that is 10 yards. And now that you have filled this in, I can ask you to write it in any of the other 3 formats. So how would you do this one? max min. You just literally grab these two numbers. But one thing that I don't see a lot, like you got to make sure you have your units there if you want full marks, okay? So that's all you would do. Like this is one way of stating the tolerance in this case, okay? We already have this, check. We're gonna go to this one, which asks us for the maximum first, which is, we've determined it's 120, plus 0, so, right, we would go plus 0 yards, minus, what is your tolerance? You have it here in this little inventory almost, right? It's 10 yards. That's it. You've written it in that format. One more. This format here, it asks for nominal. So we've got it. It's 110 yards. Plus or minus 1/2 of whatever the tolerance is. Right? This is tolerance. So tolerance you've determined to be 10 yards. So you put 10 yards here. You may leave it like this, or you can actually find out what 1/2 of 10 is if you want. I don't care. Right? Or 110 yards plus or minus 1/2 of 10 is just 5 yards. It's up to you how you want to do it. I wouldn't take marks off because it's acceptable in either format. Okay. So this inventory here would be my first step, and then use it and pick and choose what you need to basically fill in this template. Okay. Exciting stuff, eh? I know. Okay. So I'm going to ask you to do that in a bit. Let's just go down here. This one here. Which of the following soccer fields will be considered an official field? Before you do this, I want you to think of the max and the min. I think it's helpful to think that anything in here is okay. So the max we're told is 120 yards. The minimum we're told is 110 yards. I took it from my information up there. So 109, where does that go? That is over here. It's not going to make it. Not official. 110 is right on here. Is that going to be okay? Yep. 120, it's right over here. Yes. 121, it's right over here. It's outside, so wouldn't make it. Okay, so anything in here is okay, even if it's on the line, but anything that's either above or below the min or above the max would not make it. Okay, so that's another concept you need to understand here. I know this is silly, but what if they asked you to explain why 109 would not be okay in this scenario? You could probably say, well, if the field is shorter than the official length, it would be an unfair advantage maybe for the home team. They have to run a little less. I don't know. Again, the other team would also. So in this case, it wouldn't be a very good example, but sometimes they've done that. Explain why, if you're outside the tolerance, like why would you not be allowed to use it? Okay. Let's go to 41. And I want you to try 41 and 42. I'm going to walk around. You can talk to your neighbors. I want you to, from here, go to 41. I want you to fill in these 4. And then I want you to use this information to write it in the other formats. By the way, which one of these is already given here? Yeah, you figured that one out. One of them is already done. You have to do the rest. So fill in this inventory and then rewrite it into the other 4 formats. If you can do that, we're in business. All right. So go to 41 and 42 and work hard. Your employer will notice. You could be the quietest employee. If you work hard, your boss knows you're working hard. You don't have to put up a face. You don't have to say, hey, look at me, right? I'm working hard. You just work hard, they'll find out, okay? Okay, here we go. On page 42, I'm just going to do this one here. I want to make sure you understand this one. This one, oddball. Like, what's up with this one? Doesn't fit any of the categories. So if you look carefully on page 42 at the very top, it doesn't fit any of these. You might think, hey, maybe this one of these two. It's like, well, it doesn't have a 0, so it doesn't fit any of them. Don't worry about it. You still know that this front number is your nominal. That's 2.85 kgs, right? To get your max, you're just going to add. You're just going to go 2.85. Make sure you show how you got it, right? To get your min, you're going to get 2.85 minus 0.15. Okay, you're going to subtract, you're going to add. This is 3.1, correct? Kgs. This should be 2.6, no, 7, yeah. Right, so there we go. Tolerance is just subtracting these two, and that is 0.4. I'm going to stick to 2 decimals just because it kind of looks like we're sticking to the script. Everything seems to be 2 decimals, so we'll just stick with that. So this is your inventory, okay? You're doing a little bit of an inventory. It's like, I know that no matter which one Mr. Dirksen throws at me or the province throws at me, I should be able to get these 4, okay? Once you have that, you can rewrite. It's just a recipe, max, min, these 2 numbers right here. So 3.1 kg, 2.70 kgs, right? You're done. Just make it look like that, right? The next one calls for minimum, which I've determined to be 2.70. Just if you're not sure, just add a unit everywhere. Minus 0 kgs plus 0.40 kgs. They won't take marks off if you drop the 0. It's fine. Then the max, that's 3.10 kgs. Can't get any bigger, but I can go down by 0.4 kgs. And then the last one is nominal, plus or minus 1/2 of whatever my tolerance is, which is 0.4 or 40. It doesn't matter. And just to make sure, I'll add units again. Okay. So there you have it. Works every time. Works like a charm. Will I always ask you to rewrite it in all the other formats? Probably not, but you should be able to do it. You should be able to get your inventory and then go out to any of these here. Okay? All right. Feel like I should do one more. Let's go to the bottom of 42 here, bottom half, because that's the one where nominal is not given, okay? Do I have time to show you? Yes. They always send us one of these every year, okay? Teachers, like reminder, your students need to know this. And I don't find it right now, but this is the one they want you to be prepared for. Okay. So I'm just going to tell you, to get the max, this is in max min form, right? You should just recognize, oh, 2 numbers stacked. This is the form that we're given these numbers in. So just write them down. You know what 2 markings mean? That's inches. I hope you remember that. Tolerance, you just subtract them. That's 0.02 of an inch. Nominal, oh, I'm just gonna roll dice on this one or flip a coin. I'm just gonna take one of these two. I hope for the best, right? Don't do that. You actually need to add, so you need to go 0.25 plus 0.23 divided by 2. Oh, yeah, 0.24, yes. So 0.24 inches. Now you've got your inventory. Now you just put it together. I'll leave that maybe up to you to do the rest. The key is posted. Everything from 40 to 43 is posted. So if you want to double check, make sure you get it right. That's what you do. So you just got to watch out. To get your nominal, you want to use max plus min divided by 2. But don't do that unless it's in this format, okay? Because some of you might be tempted to, on your study sheet, just put this one next to the nominal. Don't do this unless it's in this format, right? I warned you. So on your study sheet, just say when it's in this format, get that, okay? Maybe give me one more day I'll figure out how to add it to your study sheet so that it makes sense, okay? We're gonna go back in time. We're gonna go to page 26. 26, okay? Go back to 26. And so just hold your finger there. But it actually started in 25 where we talked about combined uncertainty, okay? I want you to write on this, so we're actually going to 25, sorry. We're going to 25. When it says combined uncertainty, I would like you to add always add uncertainties. That is what I want you to remember when we're combining uncertainties. Just add them all up to get your combined or total uncertainty. So we're going to go to 26, and I'm going to ask you to try that one. I have a trick for it, but you need to be careful on how to use it. Here's the trick. It's not really a big trick, but I stack all the numbers I would like to add. If that's the case, I find the precision for every single one of them. And once you have the precision, you can find the uncertainty. You just divide it in half. And so if you're adding your numbers up because you're stacking wood or you're sewing pieces together or you're pouring everything into a bigger bucket, you would obviously want to add your actual measurements, but you also want to add your uncertainties, okay? Another good example is luggage, right? When you check in, everybody's luggage is weighed and put onto a big conveyor, and it stacks up, right? So they need to consider that the uncertainty keeps piling up. The amount you could be off by keeps piling up. Okay. So if you're copying this, just take a break. I'm going to go to 26 here and do it. I'm going to ask you to do it first. Okay. If you already did this, keep going. There's more on 27 or 28. At a UPS store, the clerk has received 3 packages from various customers as shown. Calculate the total weight of all boxes and the combined uncertainty. So we're just going to focus on A right now. Okay. I'm going to ask you to go 16.5 kgs, and you're going to add 2 kgs, and you're going to add 1.45. Okay, we're going to add them all up because you're combining these boxes, right? So you want to know what is the total weight of all of them. That would be partially right. You're not quite done if you were to do that. I want you to, for every single one, figure out the precision, and then from that precision, we're going to figure out our uncertainty that each package carries with it. Okay, so this is a bit of a review from last week. Find the precision, find the uncertainty. Okay, and if you already did this, keep flipping through the booklet, see if you find something else, but I think it's important for you to know how to do this. It's a very important concept. Okay, one more time, if you miss precision and uncertainty, if you're like, I sort of remember Mr. Gerson talking about it, but I don't really know what it is. Okay? You're with me, or is it too late? Let's set this up at least. The precision here, like, okay guys, another trick. If there's one decimal on your original number, you better only have one decimal on your precision. Okay? Why is this 1, guys? Why is it 1? Because you're saying that this scale, the smallest amount it can go up or down by is 0.1 of a kilogram. What's the precision of 2 kilograms? Like just a 2? It's actually a whole kilogram at a time. I know we wouldn't have a scale like that, but we're just assuming. What's this one here? 2 decimals, correct? So it'd be 0.1 kilograms. So they all have different precisions. Okay? So then we just split them in half. So this would be 0.05. This would be 0.5. And this would be 0.005. Notice how they're all different? They're all different, so it's a bit annoying. I don't want you to add the precision ever. I just want you to do uncertainty and the measurements themselves. If you add all of this up, you get 19.95 kilogram plus or minus, when you add all of this up, you get 0.555 of a kilogram. Hold on. We're not quite done yet. This is A, by the way. From this, there is a maximum and minimum combined weights that you could possibly have at the UPS store. To get the max, guess what? We're going to go 19.95 plus 0.555. To get the min, you go 19.95 minus, that's why this minus is from, you're looking, right? And so when you add, you get 20.505. When you subtract, you get 19.395. So there's a potential for you to have this much weight or this much weight because we don't know exactly. There's something, some of the rounding got missed along the way. Okay? So that's it for today. This is what I'm going to ask you to do. Okay? Make sure you try 26 to 28. That's all of this stuff, combined uncertainty. Then you try also pages 40 to 43, which most of you are done already. This has to do with tolerance. Okay? These are the 2 sets that I would like you to try, and that's all posted. Thank you, guys.